Hello everyone, I am Jay Ganesh from AML Department second year. I am here to going to explain about the implementation of K-means clustering for customer segmentation. These are the following titles we are going to see. First about the K-means clustering, objective, program code, execution and results, applications and conclusion. First let us see about the objective of the experiment. The objective of the experiment is to implement K-means clustering for customer segmentation. By applying the K-means algorithm to customer data, the aim is to partition customers into distinct groups based on similarities in their characteristics or behaviors. This segmentation can provide valuable insights for targeted marketing strategies, personalized product recommendations, and tailored customer experiences. Through this experiment, we seek to optimize clustering parameters, access the quality of resulting clusters, and derive actionable insights to enhance business decision-making processes. K-means clustering. K-means clustering is an unsupervised machine learning algorithm that partitions data into K clusters. It begins by randomly initializing cluster centroids, then iteratively assigns data points to the nearest centroid and updates centroids based on the mean of points in each cluster. This process continues until centroids stabilize or a maximum number of iterations is reached. K-means aims to minimize within cluster variance, often using Euclidean distance. While efficient and scalable, it's sensitive to initial centroid placement and assumes spherical clusters. Common applications include customer segmentation, image compression, and anomaly detection. Program code. Importing libraries. It imports the necessary libraries, pandas for data manipulation and matplotlib for data visualization. Then reading the data. The code reads the dataset from a CSV file named mallcustomers.csv using pandas read CSV function. The data presumably contains information about mall customers, such as their annual income and spending score. K-means clustering. It performs K-mean clustering using scikit-learn's K-means class. It iterates over different numbers of clusters from 1 to 10 and computes within cluster sum of squares for each number of clusters. WCSS is stored in the list WCSS. The elbow method is used to determine the optimal number of clusters by plotting the WCSS against the number of clusters. Then plotting the elbow method. It plots the number of clusters against the WCSS to visualize the elbow point, which indicates the optimal number of clusters. Fitting K-means with optimal number of clusters. After determining the optimal number of clusters, it initializes a K-means model with 5 clusters and fits it into the data. Assigning clusters. It predicts the cluster labels for each data point and adds a new column cluster to the data frame to store these labels. Then create data frame for each clusters. It creates separate data frames for each cluster based on the cluster labels assigned. Then visualizing the cluster. It creates a scatter plot to visualize the clusters. Each cluster is represented by a different color and a plot shows the relationship between the customer's annual income and spending score. Each point on the plot represents a customer and its position is determined by annual income and spending score. The legend indicates which color corresponds to each cluster and the title of the plot is customer segments. So the execution has been takes place and the result has been shown. Then the applications of K-means clustering. First is the customer segmentation. Businesses often use K-means clustering to segment customers based on their purchasing behavior, demographics, or other features. This helps in targeted marketing, personalized recommendations, and tailored product offerings. Then image segmentation. In image processing, K-means clustering can be used to segment images into distinct regions based on color similarity. It's useful for tasks like object detection, image compression, and feature extraction. Then market basket. Retailers use K-means clustering to analyze transaction data and identify patterns in customers' purchasing behavior. This information can be used for product placement, cross-selling, and understanding customer preferences. Then network traffic analysis. K-means clustering can be used to analyze network traffic data and detect patterns or anomalies in network behavior. It's valuable for network security, intrusion detection, and network optimization. Recommendation systems. K-means clustering can be utilized in recommendation systems to group users or items with similar characteristics, enhancing the accuracy of personalized recommendations in e-commerce, streaming services, and social media platforms. Conclusion. The experiment utilizing K-means clustering effectively segmented customers based on income and spending score. It demonstrated the algorithm utility in customer segmentation for targeted marketing strategies. By visually identifying distinct customer segments, businesses can tailor their approaches to better meet customer needs and preferences, enhancing overall marketing efficiency. Thank you.